So far, all our questions have used the formula as is in a plug and play kind of a situation. So we had the future value is equal to the present value, 1 plus I times n, and the information that we've been given has been able to be plugged straight into here. Yeah, we may have had to tweak the n to match the i's periods, but overall it was pretty easy to just slide it into the formula and then solve for the future value. This is not always going to be the case. So what if we were given the total interest? So we were given the I value. And then we were asked for the future value. So we don't know what the present value is. Essentially, we were given the total interest, we were given the I, the small I, and the small n. So those are the ones that we were given. So overall, we have this here and this here. And now we need to work out what the future value is. So we don't have the present value, so we can't just plug it straight into our formula. So in this situation, we can go back to what formulas do we know. We know that I is equal to the present value times I times n. And if we have I, the small I, we have n, and we have the big I, we can work out what PV is. We do that by making PV the subject of the formula. So making PV the subject of the formula would be I divided by small I times by n. Now we can put this into that original equation. So now we have that the future value is equal to I divided by I times by n multiplied by 1 plus I times by n. Okay, so it looks a bit scary, but the whole idea is if you're only given some parts, you can manipulate the mathematics so that you can end up getting the value that you need out of it. So if you get given the total interest and the actual interest percentage rate, the interest rate, and the period of the loan or the duration of the investment, you can still work out the future value by just using the two formulas that you know. So you take the total interest formula and you make your present value the subject of the formula, and then you plug it back into your simple interest formula. Again, sounds complicated. Breathe a bit. You can handle it, I promise. Let's go do an example. And what we're going to do is we're going to do the example in two ways. We're going to do it in 2 steps, and then we're going to do it in 1 step, just so you can see what we're doing here with just the formulas using numbers. Okay, so in this example, we have 300 Rand total interest is earned after being invested at a simple interest of 11% per annum for 3 years. And we ask, what is the amount to be repaid at the end of the loan? So I'm going to follow this assuming I actually don't know that I need to use the two formula kind of a situation. So the first thing I see it's simple interest. So I know I need to use the simple interest formula. So let's write that down. Future value is equal to your present value, 1 plus I times n. And I want to find out the amount to be repaid at the end of the loan. So I want the future value to be the subject of the formula. So I don't have to make any changes to the formula right now. Next up, I look at what information do I have. So what information do I have? And then I write that down just to help me out. Obviously, the more familiar you get with it, the less writing out you have to do to see what's going on. So we have 300 Rand total interest. So we have big I is equal to 300 Rand. Now, at this moment in time, you should automatically start thinking, oh, I don't have a big I in my simple interest formula there. What's going on kind of a situation? So what's going to happen? But let's pretend we didn't see that for a second and move on. And it's invested at a simple interest of 11% per annum. So we have I is equal to 11% per annum. And we're going to start doing that subscript situation. So it's per annum, so it's I1. And then we don't actually have to have this per annum sitting over there. And then we have 0.11 in decimal fraction notation. Then it's for a period of 3 years. So n is equal to 3 years. And remember, we must always check that the n units coincide with the interest units. So in this case, we can be like, okay, that's years, and that represents years. So we sorted, we don't have to make any changes. Right. We're at the end of the information that we have. So let's see what we can put into the formula. So we say, okay, well, we have I, we have n. We don't have the present value, so we can't use that formula as it stands right now because we don't know the future value either. So we have two unknowns currently. You can't solve a formula when you have two unknowns. So then we look at, okay, what isn't used in that formula? And what isn't used in that formula is your I. So what do we know about I? Do we know any formulas that include I? So we think about that and we go, oh, well, we actually do know. Let's use a proper pen, not a highlighter. We do know that I is equal to PV times I times N. Okay, and then we're like, okay, well, what information do we have? Well, we have the small I, the small n, and the big I. We don't have the PV, but we have enough to find PV there because we have one unknown in that formula. So we can make the present value the subject of the formula. So if we make the present value the subject of the formula, so we have PV is equal to I over I times N, we can get the value of PV, and then we can sub that value of PV into here. Right. So let's do it in step by step. So let's work out PV first and then put it into the formula. And then we'll look at the case where you do everything at once. Okay, so part 1, present value is equal to big I divided by I times by N. And that's going to be 300 divided by 0.11 times by 3, and that's going to give us 9.9.09 reoccurring. Then we have our second part, which is future value is equal to the present value, 1 plus I times by N, and we should carry the entire value that we worked out in part 1 across. So we should be taking 909.09 reoccurring across. You can use your memory storage button on your calculators for that, and I'll explain now why it's actually important to acknowledge this. And then 1 plus 0.11 times by 3, and that's going to give us 1209.09091, which rounded off is 1209.09. And we always use 2 decimal places when it comes to money. Now, what if we didn't take this full amount across? So what if we said future value is equal to 909.09, a rounded off amount, 1 plus 0.11 times by 3, we would actually get this equal to 1209.0897. And you're like, well, who cares? Because it works out to be the same when we do the rounding. Bearing in mind that the larger n, or the smaller the interest, it will create quite a big difference between the two of them. So there are 2 ways that you can go about making sure that your calculations are accurate. You can store part 1 into your calculator and recall it in part 2, or you can go ahead and actually just take the equation and put it into all-in-one. So an all-in-one situation would look like your future value is equal to, where your present value was, you have I divided by I times by n. Then you have 1 plus I times by n. And then you have 300 over 0.11 times by 3. 1 plus 0.11 times by 3. And if you do this on your calculator, you will get that approximately equal to 1209.09, the accurate version of it. So just bear that in mind and keep that in the back of your head always when you're going through things and when you're doing things in parts. The numbers that you take from part 1 to part 2 are going to impact your calculations overall. It doesn't look like a lot now, but it can look like quite a lot later. And actually go ahead and check that, practice it through a couple of questions and see, so that you are clear with the idea and the understanding that you should be storing your whole numbers across to your second formula. In the back of your